So I want to do a little mini lesson here on something called standard unit vectors. And we're going to see these in both two-dimensional and three-dimensional vectors and three-dimensional analysis or calculus. And so basically what a unit vector is a unit vector, or what a standard unit vector is a vector of unit length, so it's a length of 1, okay, that only heads in either the x direction or the y direction. Okay, so we're going to define them as 1. We're going to call one I, and I is the standard unit vector. It's 1, 0. Rather obviously, it's got a length of 1. Okay, that's how long it is. And then we're going to have j, and j is going to be 0, 1. Okay, and so I is the standard unit vector in the x direction, and j is the standard unit vector in the y direction. We can utilize these guys for a lot of different things, and sometimes they can be very, very handy, especially for conceptualizing vectors. It's conceptualizing them graphically without actually having to graph them. So here's how we use them. Let's say, for example, we've got a vector in component form, a standard position vector of 3, 2. The standard position vector is going to actually be 3 times the vector 1, 0 plus 2 times the vector 0, 1. Okay, and you can actually write this out. We take the scalar multiple, 3 times 1, 0, so that's going to be 3, 0. And we add to that 2, 0 when we do the multiplication, or excuse me, 0, 2. And what does it give me? It gives me 3, 2. Okay, so breaking up a component vector into the standard unit vectors is actually really quite easy. You're just going to take that x value, you'll multiply it by I, and then you'll take the y value and multiply it by j. So how we rewrite this is 3i plus 2j. Okay, 3i plus 2j. And you'll notice how I've got a little hat over the i and a hat over the j. That's how we notate these. Hat over the i, hat over the j. Okay, so we'll try it one more time. Let's take negative 4, negative 1.5. So this ends up being negative 4i plus negative 1.5j. Or we can just write this as negative 4i minus 1.5j, and that's an equivalent vector. Okay? Now this thing that we're looking at here, where we take a scalar times a vector plus a scalar times a vector, has a special name. It's called a linear combination. Okay? So this thing here, where we might write it as C1v plus C2w, is called a linear combination. And when we write something in terms of the standard unit vectors, we're writing it as a linear combination, and that's the phrase that we use. Okay? Now, what's great about these standard unit vectors is it can be really, really easy to go in and then do addition or scalar multiplication using them. So for example, let's take, for example, so we'll do some algebra with linear combinations. So let's take negative 4i plus negative 1.5j, okay, and that's our vector v. And we'll have our vector w, and w will be the one that we had before. We'll have it 3i plus 2j. So v plus w, okay, is just you're going to add the i's together, okay, and you'll add the j's together, right? And you'll notice that that just adds our components, right? Okay, that's just going to add our components together. So this is going to end up being negative 4 plus 3i plus negative 1.5 plus 2j, which is then negative 1i minus 0.5j, okay? And if you were to write that as a standard position vector or in component form, that would just be negative 1, negative 0.5. That's the addition of your vectors. So we could see something again. Let's say, for example, that I have v equals 2i minus 6j, and I have w equals just 3i. Okay? Then v plus w is then going to equal, it'll be 2 plus 3, so it'll be 5i minus, and there's no j inside of w, so it's just going to be minus 6j. Okay, and this is another way to write our vectors, right? To write them as a linear combination of our standard unit vectors. And that's basically how standard unit vectors work. One last little thing, we'll do scalar multiples. So let's say, for example, I want to know what 3v is. 3v, we just multiply the components by 3, so this ends up being 6i minus 18j. Okay? Scalar multiplication works the same way. But instead of going in and multiplying by the components, you've already separated out the components into your standard unit vectors so that you can go in and go to the addition, the subtraction, or the addition, the subtraction, the multiplication. One thing to note about standard unit vectors is we have another name for them when we work in linear algebra. They're going to be called the standard basis vectors. And in fact, we can represent standard unit vectors for any number of dimensions. All right, and essentially what they're going to be is they're going to be, right, a 1 in one of the positions, okay, and zeros everywhere else, just like our I and our J are. So we'll look at that when we take a look at three-dimensional vectors.